Okay folks, here we are for lecture 2. And in this lecture we're just looking at the basics of maths: addition, subtraction, multiplication and division. And if you want, guys, I'm only going to go through 1 or 2 samples of each one in this lecture just to try and keep it as short as possible. If you need more detail, there's a video at the end of this topic and you'll find different examples done there, so at least you'll get a little bit more detail there if you need it. But before I get into the nuts and bolts, guys, there's just a very important concept I need to discuss first. So we're going to look at addition and subtraction first. It's very important to realize that these aren't two separate things. One is the inverse of the other. They're related, they're kind of tied together. So if there's a rule for one of them, that rule will also apply for the other of them. So if we think of a tool like a hammer's really got 2 functions, but it's the one tool. One side bashes in the nail, and the other side pulls out the nail. So it's the one tool, but it's got 2 functions. One side undoes the other side. And this is the way addition and subtraction work. So one operation undoes the other. Similarly then, for addition and subtraction, these are also inverse operations. And maybe if you think of a screwdriver. So if you righty-tighty, lefty-loosey, that's something, at least if you learn nothing else from this lecture, that's a useful one. So if you turn to the right, you're going to tighten the screw. And if you turn to the left, you're going to loosen the screw. So it's the one tool, but it's got 2 functions. And one function undoes the other. You could sit there with a screw it all the way in, and then screw it all the way out, screw it all the way in. So with the one tool, you could keep doing and undoing the one thing. Multiplication and division are the same. So if we think of it, if we have, say, the number 5 multiplied by 3 and then divided by 3, these just cancel each other out. We're still going to end up with 5. They undo each other. So these are inverse operations. As long as we divide by the same number. So if we had 5 divided by 3 and obviously multiplied by 4, these aren't going to, because multiplied by 4 is different than, it's not the inverse of divide by 3. So they must be the inverse of each other. I know this seems really obvious, guys, but this concept actually ties together the whole module. So we're going to start moving into functions that you haven't seen before or you haven't really examined rigorously, like logs. So you need to kind of understand this duality of operations. One undoes the other. So if you could do something to a number with an operation, it can be undone by using the inverse operation. So with that in mind, we'll just take a look now at addition and subtraction. I'm not going to take you through the whole nuts and bolts of it, guys. Just give you a few tips, things I use. And especially if we're not working with a calculator, I know you lot are going to be sneaking calculators out everywhere, but we'll struggle on. So here, guys, you're given a column of numbers. There won't be too many of these guys in this module. So I won't get too into it. I used to examine this more rigorously previously when I had face-to-face, but I won't be examining it as rigorously this semester. Here, guys, you're given a column of numbers, and what a lot of people do is they kind of start at the bottom left and they go 1 plus 5 is 6 plus 5 is, and they start getting their fingers out. 6 plus 5 is 11 plus 4, more fingers, the toes, the shoes come out, so that's 15, 6 is 21. And it's quite hard, guys, because now you kind of carry your 2 and off you go up this column. And then you carry and you go up again. And you need to carry out, so I think it's 26 sequential calculations without making a mistake to get that sum out if you go that way about it. Which is quite a hard thing to do. Now for a computer it's pretty easy. For a human, that's to do 26 sequential calculations without making a mistake. So that's why, even though this is easy, inverted commas, it's not. It's not easy at all. So to make it easier, guys, what I do is this. I actually look for pairs that add to 10. So I go 6 and 4, that's 10. 5 and 5 is 10. And 1 left over. So that's 21. And everything is taken care of. I cross them off as I go. Now I carry my 2. Now 8 and 2 is 10. 7 and 3 is 10. That's 20. And now I've got this 2 and this 4. That's 26. These guys all add to 10. 2 carried, plus 2 plus 6, that's a 10. There's another 10. And 8 left over, so this is 28. Hope I don't make a mistake here. So here we've got 6, I'm looking here. There's a 10. And then I've got 6 and another 3. 10 plus 6 is 16 plus 3 is 19. So there, guys, I'm only adding 2 or 3 numbers together to get a 10, and then I'm adding up my 10s. It's a lot easier. Again, take it or leave it. I hope that's the right answer. Yes. Sorry, guys, this is very annoying. I often do these and I get them wrong, so it's quite frustrating, especially when you're supposed to know what you're doing. So that, guys, is just the tip. Just give it a go. If you like it, take it on board. If you don't, and like I said, there's not going to be a whole lot of these ones. I think there's a few of them in the quizzes. So see if you can just practice that technique. It's a good one. So here, guys, is just one for you to try. So pause the video, give it a go. I'll keep going. And now we'll take a look at subtraction. So here, guys, with subtraction, most people, there's a few different ways of doing it. I'll show you the way I did it. There's another way which I'll also show. And you can take either of them. I don't mind. As long as you're getting to a right answer, guys, I don't mind. That's really, there's loads of different techniques for doing additions. Not so much addition, but subtraction, multiplication, long division. There's lots of different techniques employed around the world. As long as you're arriving at the right answer without a calculator, I'm reasonably happy. So now, here, guys, we go for subtraction. 7 from 3. 7 from 3 won't go. So I was old school. I was taught back in the old days. So we used to always borrow off the bottom. So I would borrow here. And so I would say now 7 from 13 is 6. And now I'd pay back here. So now I'd have 1 plus 9 is 10. 10 from 2 won't go. I'd borrow another 10, or 100 in this case. Now 10 from 12 leaves 2. I have to pay back. This is 9 from 10 is 1. Again, I had to borrow. I pay back. 3 from 3 is 0. So my answer there is 126. So that's one way of doing it. That's beginning to fade, unfortunately. The other way, which I do like, and this is the way most of you guys would probably do it, is just borrow off the next number on the list. So here we'd say 7 from 3 won't go. So I'm going to borrow off of him. And I actually think this technique makes more logic. So that goes to 1. And there's my 13. 7 from 13 is 6. Now I have 9 from 1 won't go. Again, I'm going to borrow off of here. So this will go to 9 and he'll go to 2. So now 9 from 11 leaves me with 2. 8 from 9 leaves 1. And 2 from 2 is 0. So I arrive at my 126. And again, guys, whichever way you prefer, I'm absolutely fine with that. So we'll move on slowly. And now I'll let you guys have a wee go at this one. So just have a wee go at it, see how you go. Sorry, I should have the little pause symbol here. I don't, but pause the video and just give this a quick go. I'll keep going then. I'll presume you've paused. I'll take a look. Now, first thing, guys, is this is actually set up to trick you. And I'll show you how it goes. So you'd go 0. If you tried to do it just the way we did it without really looking at the numbers, 0 from 0 is 0. 6 from 9 is 3. 4 from 3 won't go. I'll borrow 1. 4 from 13 is 9. And then you're going, oh, I pay back, or It's either 6 from 5, or we'll just go the way we were doing it. So 6 from 5, and people then go -1, and it just feels wrong. And the reason for that, guys, is because it's wrong. It's completely wrong. And subtraction can't work that way. What you're actually doing, guys, with subtraction, what we commonly call subtraction, what we're actually doing is finding the difference. And it's really a number line problem. So if we were to talk about this in terms of, say, money, say you've saved 6,390 euros and you want to buy a nice car, and this is the price on Done Deal. So you know intuitively that you don't have enough money. So this is what you have. We're onto the number line problem. And we know we're going to have to step back 6460. More than anything, guys, what you need to know is your answer is going to be negative. So establishing the sign, guys, is so critical. And now we're kind of wondering, well, where are we going to end up back here? This, guys, is the difference. And when you're subtracting, that's what you're looking for. So we're wondering, where are we going to, sorry, this is the 0 line. I haven't made that clear. And then it goes 1, 2, 3, all the way up to 6,000. We know we're going to end up in the negative side, but we're not sure where that's going to happen. So what you have to do, to get the difference between the two values, guys, you always have to put the biggest number on the top. Now I've kept the minus with it because that's the negative. And now just from that logic with the number line, you know your answer must be negative. And now we can do the sum. 0 from 0 is 0. 9 from 6 won't go. 9 from 16 we'll borrow. 9 from 16 is 7. 3 from 3 is 0. And 6 from 6 is 0. So the answer there is -70. You'd need to borrow 70 euros to pay for that car. So that's a very important concept, guys. The calculator does that automatically. So it's very easy to make thinking you're doing the right thing, not paying attention. And again, this is one of the reasons why I try and go back to the basics, because these are all the things you've forgotten along the way. And the calculator kind of hides this lack of knowledge from you. As a scientist, you've got to be able to handle numbers competently. And that's what we're really looking for here. So it might seem like torture, guys, but there's kind of a very firm logic behind what we're doing with this module. We're trying to really strip back to the basics and build from there then. So please bear with us. So now, guys, we'll take a look at multiplication and division, but very importantly, always try and estimate first. So I'll discuss estimation in terms of multiplication and then the technique, and then I'll discuss estimation in terms of division and then the technique. So that's the way things will go. So say if you're asked to estimate the value of these. Now, I'm not asking you to work out the answer. We'll come to that in a couple of slides. We just want to get the order of magnitude of the answer. And the order of magnitude, guys, is my answer in the tens? Is it in the hundreds? Is it in the thousands? Is it in the tens of thousands? Is it in the millions? That's the order of magnitude. I don't really care, is it 20,100? I just need to know, is it in the 10,000? Somewhere between 10,000 and 99,999. That's all I want to know. So that's what we're looking for with our estimate, guys. What another way of putting it is, have I put my decimal point in the right place? Thinking back to the coffee example from the introductory lecture where the people were overdosed with 30 grams of caffeine instead of 0.3. You know, simple maths gone wrong, and it could have been with fatal consequences. So this is where we're going. This is why we estimate first. It's very simple. Bring each of these numbers. So this number here is very close to 500. This one is very close to 400. So this is what we're thinking. Now, guys, we just multiply the first two numbers. 5 by 4 is 20. And now we count how many zeros are left. There's 4. And there's my estimate. So that's all we're looking for, guys, with an estimate. You should be able to do it without writing anything down. If you do write anything down, it should be just one line like this. No hard sums. The idea of an estimate is to get the order of magnitude. I know now my answer should be in the hundreds of thousands. So if I get 20,000 and something's gone wrong. And this is why we do this first, guys. You always estimate, and then you work out and you check that the two answers have the same order of magnitude. So this is our estimate, and there, guys, is the true answer. But we'll get on to how we got that very shortly. So now have a quick pause, guys, and estimate these ones. So hopefully you've paused, had a go. I'll just change my pen color actually from the red. I should have done that at the start. So this, guys, I would say is 800 by 100. 8 by 1 is 8. And 4 zeros. So my answer is in the tens of thousands. That's what's crucial. The 80 gives me a good guide of how close I am. When I work out the true answer, I see it's this, and both of these are the same order of magnitude. They're both in the tens of thousands. That's what my estimate is about. Here's another one, guys. Have a quick go at this. So we'll take a look. 2,000. I will bring this value to 500. 2 by 5 is 10. Make sure to write that 0 of the 10. And now, guys, there's 3 zeros plus 2 zeros. And there's our estimate. So my estimate is somewhere in the region of 1 million. And now when we work out the true value, that's what we get here. So now, guys, need you to pause, and this is one of your questions. Estimate the volume of this tank. Similarly, estimate the volume of this tank here. So again, pause the video in the appropriate places. Have a go. Make sure to label these questions correctly so that when you need to retrieve them under pressure in the end of module assessment, that you can do so really quickly. So make sure you take notes, guys, and you store those notes carefully. So now we'll take a look at the nuts and bolts of multiplication. I'll try and make this as painless as possible. Nobody ever likes long multiplication or short multiplication, guys, so just bear with it, and a little bit of practice, you will get good enough. And one thing, guys, the course is not filled with this stuff at all. Most of the maths on the course can actually be done in your head, believe it or not, an awful lot of it. But it's all about, are you applying the correct technique? That's what I'm always examining. The maths itself will usually cancel out very easily, and with a little bit of forethought, you'll actually work out stuff quite quickly without a calculator. I put a lot of work into kind of designing the course that way. What I'm always looking for is, are you going in the right direction all the time? So here, guys, this is short multiplication because we're multiplying by a value less than 10. And you just say 7 by 3, that's 21. Lots of ways of doing this, so whichever way suits you, that's good. 7 by 3 is 1, carry the 2. 7 by 2 is 14. Add the 2 is 16. 7 by 1, 7, add my 1, and that's 816. Sorry, I should have estimated first. So my estimate, 7. You could have also estimated 100 by 10, but it's easy enough, 100 by 7. That's a fairly straightforward estimate. So here's my answer here. So that's short multiplication, and I think most people are kind of adept at that. There's videos at the end of the topic if you want to explore it in a bit more depth. I'm not going to go through loads of these. Now, long multiplication. Now again, guys, think of your estimation. So I would say here, this I would think 100 by 30. And that's going to give me, 3 by 1 is 3. That's them taken care of. And I have 3 zeros. So there's my estimation. And now we'll go through the process. Now, I've already done this, guys, on the previous slide. The first one, 7 by 1, 2, 3. That's 816. Now, I'm going to multiply by 2 here. But it's not 2, guys. It's actually we're multiplying by 20. So to take cognizance of that, you always write a 0 here to indicate you're multiplying by tens. So now, we'll have my 0 there. 2 by 3 is 6, 2 by 2 is 4, and 2 by 1 is 2. We add these values, carry the 1, 12, 13, carry the 1, and that's my answer there. So that was the first one, and there was the second one, and we can see my estimate and my answer both have the same order of magnitudes. They're both in the thousands. They're both 3000, which is good, but the main thing is they're both in the thousands. We'll explore this a little bit further, guys. We'll do multiplying by hundreds. So now we have 123 multiplied by 127. So a rough estimate, I'd say 100 by 100, and that'd give me 1 by 1 is 1, and then 4 zeros. Now, if you were happy enough, guys, you could kind of say, well, 120. If you're happy enough, we go, okay, I know 12 by 12 is 140. 144. And then 2 zeros. So sometimes if your maths is a little bit kind of stronger, you can go for a closer estimate. So there's our estimates depending on what level, but you should always be able to do an estimate, guys, in your head, back of the envelope, like 5 seconds. That, you should be able to be working it out as you're writing it. If you're doing this 3, 2 by 1, 3, and then you're doing something wrong, guys. That's not an estimate. That's just making more work for yourself. So it should be something really simple. So now I've done the first 2 layers, 7 by 1, 2, 3, 2 by 1, 2, 3. Now, guys, when I'm multiplying by the 1, I'm actually multiplying by 100. So I recognize that with 2 zeros there. And then I start 1 by 3 is 3. You can see I picked nice easy values so I don't screw it up too bad. 1 by 1 is 1. And now we add all of these. And I'll just get us there. And that's my answer. So now we can see again, guys, the order of magnitude of my estimates and my answer are the same. We're in the tens of thousands. My easy estimate, it's very easily arrived at. It's a little bit out, but it's bang on for order of magnitude. And that's where the errors, guys, come in. As soon as we start looking at decimals, you're going to start asking yourself, well, is it 1.5 something? Or is it 15.6? Or is it 156.2? Or is it 1,500? And these are the errors, guys, that cause fatalities when you apply them to a clinical medical scenario. So this is why we got to be really careful, and this is why we've got to build good technique. So now, guys, this is one of your questions to be examined. So first of all, estimate. That means do our estimate. And then evaluate. That means do the full long multiplication. So I'm going to let you at that. I'm going to move on. And this is the kind of stuff, guys, we're going to encounter very shortly. Really long multiplication. And I think you'll agree that that previous technique is not going to be much fun, so we don't choose it. Now we're going to take a look at division. And division can be represented in lots of different ways. As a fraction, using the oblique, as it's called. That slash is called the oblique. Or using the divisor sign. They all mean the same thing. What's crucial, guys, is identifying the divisor. What's being divided in. That's the crucial bit. Be very careful. Because often, guys, in this module, you might come across this. 15 divided by 360. That's a completely different thing than this. So just be aware, in this case, 360 is the divisor, even though your instincts are to divide the 15 into that number. So watch for that, guys. Always identify the divisor. So this is where I was saying I really identify where people make mistakes. This is one of the mistakes. In science, guys, it would be very common to have a small number divided by a big number. Very, very common. This is where all our 0.000s come in. And we'll be exploring this in great detail in this module, this world. The world of milli and micro. So that's why, guys, I'm emphasizing this stuff. These are where the mistakes are made. A divisor sits in these positions. Just because it's bigger than the other number doesn't mean anything at all. So if the divisor is 10 or less, then we use simple division. I'll run through a quick example of that. If the divisor is greater than 10, then long division is used. And there's lots of different methods of long division, guys, and short division. As long as you're getting to the answer correctly without a calculator, it's valid. You'll get full marks in any kind of test. So you don't have to follow my method. That's what I'm trying to say. Enough said. So now, first of all, guys, we take a look at estimation before we get into the nuts and bolts of division. Bring each value to the nearest kind of easy number. So I'd say 700 divided by 20. I always write them above each other like this. Because now, guys, I can divide the top by 10 and the bottom by 10. And I've got 70 divided by 2. So my estimate is 35. So we just divided top and bottom by 10. That's why I write them above and below each other like that as a fraction. So this is our estimate. When we actually work out the problem, the real answer is 34. So our estimate and our true value are very close in this case. So now you guys have a wee go at this one. I'll just let you have a quick go, just see how you go. So what I would do here, this value, very close to 1,000. This value, very close to 20. Make sure, guys, you put the divisor in the right place on the bottom. I know it seems obvious, but you will be tempted to do the right thing. So now, guys, this is straightforward. Divide top and bottom by 10. 100 divided by 2 is 50. So that's your estimation, guys. Like I said, you should always be able to do it in a couple of seconds. It's a very good idea, guys. This is something I need to emphasize, to make sure that this number, I'd nearly always round the divisor first. Okay, go for 20. Now when I go to round this one, I want to make sure that 20 will divide easily into whatever number I round to here. And you can be a bit flexible there, guys. It is estimation. So now, you guys pause and have a wee go at these two here. And just to emphasize what I was saying earlier, you could go for 30,000 on the top here and 40. but they don't go in nicely. So I'd be kind of thinking 32,040, because I know 4 will go easily enough into 32, goes in 8 times. So I'll let you guys practice them. We'll push on and we look at simple division. My divisor is less than 10, so I set up my simple division like this. My divisor goes outside, the number goes on the inside, and now we just say 9 into 3. Now this is important, guys. 9, we divide each number in sequentially. 9 into 3 won't go. I'm only writing this in, guys, as a placeholder. You do not write anything there. Now we can say we can carry the 3 over. 9 into 31 goes 3 times with 4 left over. 9 into 40 goes 4 times with 4 left over. 9 into 43, again that's going to be 36 with 7 left over. And 9 into 72 goes 8 times. Now I'm very annoyed at myself because I should have estimated first. So my estimation in this case, I'd say 30,000 divided by 10, and my answer is somewhere in the region of 3,000, which validates the true answer there. Now, one thing, guys, is the idea of decimals. I'll discuss decimals in more detail in a later lecture, but just to bring it in here. So say if this wasn't 31,000. So now if I needed to keep going, so sorry, we had a 3, 4, 4, 8. And if necessary, if I needed to go to a certain level of accuracy, this decimal point can be brought in, and these trailing zeros, they're called. And this is where we start to get into, problems that don't resolve easily. So say if I was asked to divide this value by 9. Now it would be the same, 3, 4, I'd have 4 left over. Sorry, I'll write in these. 4, and now I've got 7 left over. 9 into 70 goes 7 times, that's 63. And I've got 7 left over. So this is where I bring in my decimal point. Now what really happens here, guys, is the decimal point just drops down here. I'll just get rid of that. And you can kind of forget about it up here. So now we've got 9. There's my 7 carried over. 9 into 70 will go 7 times with 7 left over. And off we go. This will just become a recurring decimal. So to check that I'm having momentary fear that I've made a mistake. No, I think that's okay. So that, guys, is how your decimal works in division. But we'll look at division and decimals in kind of lecture 3 as a separate topic. But it's just to introduce it here. So now, guys, we'll take a look at long division. I'm going to estimate first. Now we're thinking 8,000 divided by 60. And I know myself that these aren't going to go in easily. So I'm just thinking, then you don't want it to go on too long. So 800 divided by 6 is going to be somewhere around 100 and something. So I know 800 divided by 6, 1, 2 left over. And here, guys, you can just kind of go 3, and we know my answer is somewhere around 130. That's what your estimate is about. So here we're bringing short division into the estimation, but I'm estimating somewhere around 130. And now we'll take a look at the maths. The 62 is our divisor. This goes in. I'm worried I might need my decimals, so I'll just write them in at the moment. I might need them. I'll leave them out. you know, so it's up to you depending on your levels of suspicion at the start. Now, this, guys, again, is covered in the video. It's quite a technique. It takes a little bit of practice. What you're actually going through is a cycle of divide, multiply, and subtract. We're nearly at the end as well, guys, in case your head is popping at this stage, which I'm sure it might be. This is one of the longer videos. So what actually happens, guys, is we divide, multiply, subtract, and this continues in a little loop. So first thing we're going to divide, 62 into 79 into 7 won't go. Sorry, 62 into 7 won't go. And I write my little placeholder up there. That's very important. You can kind of carry the 7, but now I just say 62 into 79 will go once. So that's the multiplied. Now we multiply 1 by 62. Sorry, that was the division. 62 into this goes once. Now we multiply 1 by 62 is 62. And we subtract. 2 from 9 is 7. 6 from 7 is 1. This 9 now, guys, will travel down. And this cycle now starts again. 62 into 17 won't go. It shouldn't, because we'd have made a mistake. But 62 into 179, it's nearly 3 times, but it's not, because 3 times would be 180. So it's going to be 2 times. So that's the hardest bit, guys, is that division. So 62 will go into 179 2 times. And sometimes, guys, you might have to go off and do a little bit of rough work. 2 by 6 is 12. Oh, and I can see a mistake there. Phew. So 2 by 2 is 4. Yeah. And 2 by 6 is 12. So this is 1, 2, 4. So that's the multiplication stage. And now we subtract. 5, 5, and they'll cancel out. This now, 5, 5, 8. I'm kind of thinking, well, 10 62s would be 620. This is a bit less than that, but not much. So I'm going to go for 9. And again, I'll just rub all these out. And now 9 by 62. This is the multiplication stage, obviously. There's 8, that's good. 9 6s, 54, and 1, 55. Now it's very important, guys, to close out the problem and show that there's no remainder. So in this case, guys, we don't actually need our decimals. If we did, this decimal point would move up, and we'd keep dropping these zeros down as we need it. But like I said, we'll discuss that in a later lecture. So now, guys, this is one of your questions. Estimate and evaluate. And then in an exam situation, guys, I am going to be looking for the estimate more than the evaluation. The evaluation means calculate, and I will always suspect you lot of sneaking in a calculator somewhere. So I'll always be looking for your estimation, well, not always, in general, because that shows more understanding than producing the answer. I know that sounds weird, guys, but I'll always be kind of trying to veer you away from the calculator. But you're going to need both answers, one way or the other. But just this, to me, often shows more understanding this than this. I hope that makes sense, just because I'm a suspicious kind of person. So that, guys, finishes the lecture. So thank you for your patience, and this concludes the first week's work. You should now be kind of prepared to take the 2 CA tests. You should have 2 passwords, one from the first lecture, one from the second one. And you should be now kind of primed to take your 2 CA tests. You'll also see there's quizzes on Moodle to allow you practice these skills. So thanks for watching, guys, and I'll chat to you again in lecture 3.